part though. I'm so happy that I feel better though. I'm like such a good mood. Okay, so can you please go to the y equals in your calculator and type in the equation for number 18. So x to the third plus 2x squared plus x plus 2. Okay, and the goal here is to find a root. So we want to find something that we can divide by, so we can start to factor this problem. So once you have this typed in, hit graph. Okay, and then let me know if you found a root. Does anyone see a root? Yeah, okay, so you're right. I'm going to write this way. X equals -2. I'm going to write it slightly above the problem. And then I'm going to write divided by x plus 2. So that's where I'm going to flip the sign into a factor. Okay, now on this problem, can you guys tell that I'm going to have some bad news? Can anyone tell that I'm going to have some bad news? Okay, so what degree is this? 3. So that means there needs to be 3 roots. How many of them are real? 1. And the other 2 are going to be imaginary, which means quad formula. Yay. Okay, but let's do this bit. So we want a 3x2 box. X cubed plus 2x squared plus x plus 2, x plus 2. Okay, and more problems. I'm having all kinds of Monday issues this morning. All right, so x cubed. So this has to be x squared. And this has to be 2x squared. All right, so this is kind of a interesting, different situation. If I have 2x squareds and I only need 2x squareds, how many more do I need? 0x squareds. And if I were you, I wouldn't just put 0 there. I would keep the variable going because it helps you keep moving with the rest of the... Actually, that 0x is really good news for us. We don't have to do quad formula then. Okay, so we have 0. We need 1. So this is going to be 1x. Check. Party emoji. Okay, so we can tell that this factors into this times this. Let me say that again. This factors into this times this. So x plus 2 times x squared plus 1. You don't need to write the 0x in at that point. Okay, let me ask you this. Is it possible to box and diamond x squared plus 1? No, but that's okay. Okay, so this part I can do in my head. X plus 2, I know that that's x equals -2. And this part I'm not going to do in my head, so I'm going to set it equal to 0. And what is the square root of -1? I. Perfect. Okay. So degree 3, 3 answers. Do you see my 3 answers? Okay. And it didn't tell me to describe them, but what would be the description for this one? Yep, one single real root and two single complex roots. And then I want to tie that back into the graph. So there's my one single real root, and I have 3 directions, but notice it does not come back across the x-axis. So the complex roots, you don't go back across the x-axis, but you make sure you have 3 directions. Okay, great. Scooch on down to number 19. And these problems, what's the last time we did this? Before Christmas, I think. I like to do these with the table method. I'm sure that Miss Rice showed you both the table method and the systems method. I'm not a systems method fan, but if you like that, by all means, go ahead. Okay, so let's review how to do this. So I have 2 points in an asymptote. The first thing I need to do is undo the asymptote on the y's. So this point is 1, 0.845. And this point is 4, 1.85645. A little bit nervous about these decimals. I don't know about you. Okay, so step 1 is to undo the asymptote on the y coordinates. Okay, and then make a table, but you always need to make room for 0. So mine go from 1 to 4, so I need to backtrack and make sure that I put a spot for 0 in there. And then 0.845, 1.85645. Man, that's really specific. Okay, any questions about that so far? Is it coming back to you? Okay, how many B's does it take to get from 1 to 4? How many B's does it take to get from 1 to 4? 3 B's. Okay, so I write myself an equation. 0.845 B to the third is 1.85645. Divide. I'm a little bit nervous about the answer. You guys get 2.197 something? Yeah, okay. Okay, cube root both sides. Oh, 1.3. It wasn't that bad. Okay. And do you guys remember how to go backwards on the table? What do you do to go forwards on the table? Multiply. So backwards on the table would be divide. Okay, so final answer, y equals a times b to the x plus k. All right, everybody, you can switch that to the side and grab your notebook. Okay, so this is the lesson, basically, this is the last one of the chapter, and it's where we're gonna bring everything together. So we're going to factor all the way. We're going to use the factored forms to find and describe all the roots. And we're going to use the roots to sketch the graph as best we can. On this one, we're gonna cheat a little bit and use the graphing calculator. And it's not actually to look at the graph or the sketch. It's actually to determine a root so that we know what to divide by. Okay, now, the thing I need to tell you is that this one is degree 4. First of all, does that make sense? Degree 4. Okay, which means that there will be 4 answers, 4 roots, and 4 directions in my sketch. Does that make sense to everybody? Okay, and it's also kind of bad news. So the ones we did in the warm-ups were cubics, which means that we only had to do polynomial division once. When it's a 4th degree, you have to do it twice because we only know how to box and diamond and quad formula. It's not the cube formula, it's the quad formula. So we're gonna have to take it down to a cubed, then take it down to a squared. So whenever you see problems with the 4th power, you're gonna go like, oh no, Mrs. Talbot, how could you? Okay. I want everyone to take their graphing calculator first and type in this equation. And I want you to do 2 things for me. I want you to look at the graph. Okay, so first of all, are there 4 directions? Yeah. How many roots are real? Okay, let me ask you this a different way. How many times does it cross the x-axis? 4. Okay, so 4 real roots, 4 degree 4, 4 directions, that makes sense. Do you guys see why this particular graph might be misleading? I picked this one on purpose. You guys look at this and you see it bounce, but it isn't one. Okay, so how are you sure? Go to the table. So everyone go second graph. No, I guess it is one. Okay, wait. Yeah, no, it is. Okay, what I'm trying to say is this guy here is not perfect. So you might say, you might say -2, -1, and 2, but this one's not perfect on -2, is what I was trying to get at. So what we do is we look at the table just to kind of help ourselves figure out what actually are roots. It gives us exact answers. And what you want is the ones with something comma 0. So 0 in the Y column. I'm going to take this information and just sketch it, just jot it over here. So I know I have a root at x equals -1. And I know I have a root at x equals 2. And just hold that thought for a moment. So take a look at the table. It'll give you exact values. And this one, I'm going to change to the factor of x plus 1. And this one, I'm going to change to the factor of x minus 2. I think that one's going to end up being a double from the way it looks. Okay. All right, so I'm going to make a 4x2 box. And I'm just going to divide by the first one. It doesn't matter the order, it'll come out the same in the end either way, but I'm just going to divide by the first one first. X to the 4th, x cubed, x cubed. Okay, I have positive x cubed. I need negative x cubed. So this has to be -2x cubed. I have -2x squared. I need -5x squared. So this is -3x squared. I have -3x. I need +3x. So that has to be 6x. Party emoji. Okay, now I'm going to write a factored form here. So this is my current status. I know that this, my original problem, factors to be this times this. Okay, cool. So that's kind of like my current status. Okay, now I have a cube. So I'm going to make a 3 by 2 box. Now maybe you can see where this is going. I hope you can see where it's going. And I'm going to take my cubic and divide it by the other root that I got off of the graphing calculator. And party emoji. Okay, so what is my current status? So I have the x plus 1 from my previous problem. And this factors into this times this. So x minus 2, x squared minus 3. Okay, can I factor x squared minus 3 any further? Can you box and diamond x squared minus 3? No. That's as good as that's going to get. Okay, so that's factored all the way. Factored form, all done. Okay, and we're going to use that to find our roots. So we have x equals -1, x equals 2. Oh, I was right. It's not a bounce. X squared minus 3 equals 0. Do you guys see why I can just skip straight to the x equals, but I didn't for this one? Does that make sense? Are you sure that makes sense? Because like this I can do in my head, and this I can do in my head, but this I can't really do in my head, so I have to hit equals 0. Okay. Plus 3. X squared equals 3. Square root x equals plus or minus the square root of 3. Okay. Done with that so far. Okay, now I need to describe them. What type of root is this? Single real. What type of root is this? Single real. What types of roots are these? Single reals. Reals, no i's in there. Reals. Okay, so my description is just going to be 4 single real roots. Okay, and now I'm going to just sketch the graph as best I can. So I have x equals -1, x equals 2, and then I'm going to say, I don't remember what the square root of 3 is. Actually, I do. It's 1.7. But anyway, so I'm going to go, okay, I also have roots at positive 1.7 and negative 1.7. And my A value was positive, so I need to come from the top, right? So I'm just going to do my best. Sketch. Do you guys see how this is like misleading right here? Yeah. Okay. We have one more to do. And look, it's a cubed. Aren't you excited? The directions for this problem are the same. Why is it named Q? I don't know. Just felt like it. Okay. So you're staring at one of these problems. What do you do first? What is the very first thing you do? Graphing calculator. Okay. Everybody type it into the graphing calculator. Look at the graph and look at the table. See what you think. All you have to do is scroll up there so it's blinking and then hit enter and that turns it on. Dang it. Can you guys tell why I said dang it? You're gonna have imaginaries. Ah. Okay, anyway. So I looked here. I suspect that there is a root at 1, but I'm going to confirm with the table just to make sure that it actually says 1, 0, and it does. Everybody good with that? Okay. So I'm going to come over here, root at x equals 1, which is the factor x minus 1. Okay, step 1, get a root. Now I want to show you something on your packet real quick. For those of you that don't have a graphing calculator at home, you can always use Desmos. But on your review assignment, just so you know, we gave you a root so that you didn't have to use a graphing calculator. You could just use the root that was given. Okay, anyway. All right, now what size box do I need? 3 by 2, do you see it? Okay, make yourself a 3 by 2. Okay, x cubed, x squared, negative x squared. Four x squared, 4x, negative 4x. Five x, 5, negative 5, party. Okay, so what do I have so far? I have Q of X equals, so this factors into this times this. Okay, now technically, I'm supposed to attempt to box and diamond this. However, we already know because we looked at the graph that it's not going to work, but just because we're making sure that our notebook looks nice, you're supposed to try to box and diamond. And it doesn't work. I don't know what is, there's a gravity problem over here. There's some kind of gravity issue. Darn it with the gravity. Okay. Okay, pausing there. So does my process make sense so far? So I got a root from the graphing calculator. I used it to divide. It came out evenly, which it should if it's a root. Remember, that was the factor theorem. If it's a root, it should come out evenly. And I wrote my current factor form, and then I attempted to factor that. Now, what if it did factor? What if the box and diamond worked? Then I would just put little arrows and find the roots and describe, right? Okay, but sadly, it doesn't work. So what do? Your favorite. Oh, you know you love it. It's quad formula. Okay, so first I can go x equals 1 here. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay. Negative 4 plus or minus square root 16 minus 20. Negative 4 plus or minus the square root of negative 4 over 2. Okay, what's the square root of negative 4? 2i, right? So the 2 from the 4 and the I from the negative. And then reduce. Okay, so I have one single real root from that. And I have two single complex roots for this. Okay, and I'm going to sketch the graph. And it's just going to be a sketch because we don't know how to graph I really. Okay. So here's my x equals 1 is right there. Now we don't know how to graph these, but we know that it's degree 3, which means it needs to have 3 directions. And we know that it's a positive A value, so it needs to start low. Okay, so this is what I'm going to tell you. I have a working theory with Jacob, Ryan, and Matthew. You guys know who Jacob, Ryan, and Matthew are? Okay. They are math enthusiasts, I will say, and the least bit. Jacob, Ryan, and Matthew have a Mrs. Talbot, Jacob, Ryan, and Matthew theorem, which says that the bounce for the complex roots will happen a lot of time at the number in front of the plus or minus. Okay, let me say that again. The bounce for the complex roots, the bump, not a bounce, I shouldn't use that word. The bump for the complex roots happen a lot at the number in front of the plus or minus. So take a look at your graphing calculator at the graph. Hey, Caitlin, this is what you were asking me about last week. So what I'm saying is the bump for the complex roots happens often at the number in front of the plus or minus, which means I can make my bump at -2 below. Aren't they smart? Okay, so just going to make it like this. Okay, so it might look something like that. 1, 2, 3 directions. And the bump for my complex might happen. And we pretty much spent the entire chapter when we did these, we looked at every single one. And I think almost all of them worked. I can't remember the circumstance of which we figured we couldn't, like, publish an article in a math journal. There was like something that happened, or like, maybe it's not all the time, but anyway, that was our theory. And I really think that you probably think now that you wish I would have showed you this when you were doing the quiz 2 review and you're trying to figure out where to put those complex bumps, but that's because I'm not really sure if it works all the time. Okay. So that's that, guys. Now can you look at the stamp sheet, please? Okay, so here's today. Homework tonight is 4 CP/M problems. I would love to stamp anything that is late or absent. I don't need to stamp your whodunit, your dividing polynomials worksheet at this moment, but if you have anything that's like missing from areas that you would like me to stamp, please bring that over. Otherwise, go ahead and work on your homework.